So in these questions, what we're going to find is that you want to solve for the amount of the deposits or the amount of the withdrawals. So with our two formulas for savings and payout annuities, with these we want to solve for D. So the idea being that you want an idea of how much can you withdraw each month if you've saved up a certain amount in a retirement account. Or if you want to save up to buy a car, how much do you need to put into an account, a savings account each month in order to have the correct amount when you're looking to purchase that car? So up above here, I rewrote our savings and payout annuity formulas. So we're going to use these, but let's look at these different scenarios and talk about how to solve them with our calculator. So this first scenario, you have $375,000 saved for retirement. So there's our balance for the account. Your retirement account earns 4% interest. How much will you be able to withdraw each month if you want to be able to make withdrawals for 20 years? So from this information, we have A equals 375,000. We have R equals 0.04. And then we want to find what D is. We want to find the withdrawal amount. And then we have T equals 20 for 20 years. Oh, and our withdrawals are going to be monthly, so N is equal to 12. Now, because we're withdrawing for an account, this means we're going to use the formula for a payout annuity. So we're going to use A equals, so 375,000 equals D times, so parentheses, 1 minus 1 plus 0.04 over 12 to the negative 12 times 20, all over 0.04 over 12. All right, so looking at this, we want to solve for D. And what we could do is even bring that D out front of this equation, or not equation, but this fraction, I guess is what it would be. So like having D out front times this whole fraction with this information. So what we're going to do is with a calculator, it's going to help us simplify. So we're going to have 375,000 equals D times, and then we're going to plug in that whole fraction to the right of D. So let's go to our calculator and let's set up our fraction. And we're going to have parentheses. We don't really need those first parentheses. So we're just going to do 1 minus, in parentheses, 1 plus 0.04 over 12. And then an exponent of negative 12 times 20. All over 0.04 divided by 12. So it's a 165, and I'm going to go to 4 decimal places here, so 0.0219. And actually, the more accurate we can be, the better. So while I'm going to write that on my paper, I'm going to actually use that exact amount from the calculator. Because now what we have is D times that 165. So what we're going to do is divide both sides by that 165 number. So really what I can do is in my calculator, I'm just going to take 375,000 divided by, and then that answer to the question up there. So I'm going to use the answer button so it'll copy and paste for me. So $2,272.43. 2272.43. So with this, if we have $375,000 saved and we want to make withdrawals each month, we can withdraw $2,272.43 each month for 20 years. All right. With this next one, you want to have $170,000 in your account when you retire in 30 years. Your retirement account earns 7% interest. How much do you need to deposit each month to meet your retirement goal? So with this one, we're building up our account, so we're saving money. So this is a savings annuity. And what we want is a balance. So A equals 170,000. We want to do this in 30 years, so T equals 30. We have a rate of 7, and we want to know how much do we need to deposit each month. So we want to find what D is, and it's working monthly, so N equals 12. So we have 170,000 equals D times, I'm going to have the D just multiplying out front, so it's kind of separated. And then with our fraction, with the savings annuity, so we'll have those double parentheses, 1 plus 0.07 over 12 with an exponent of positive 12 times 30. And then minus 1, close those parentheses, all over 0.07 over 12. All right, so I want to simplify what's to the right of D there. So we're going to go D times. And with that, we're going to separate up our fraction. We'll have parentheses 1 plus 0.07 over 12. And then an exponent of 12 times 30. And then a minus 1 all over 0.07 over 12. So 1,219.971. And again, I'm just going to write that down, but in fact, I'm just going to go ahead in the calculator. We're taking the 170,000 divided by that value. So I'm going to go 170,000 divided by, and then I'm just going to use the answer function in the calculator if I can get my screen to work. There we go. 170,000 divided by that last answer we got, so it'll copy and paste. So 139.35 is our value for D. So D equals 139.35. So if we deposit about $139 each month for 30 years with this account, we should be able to get to our savings of $170,000. All right, our last one here, we have a donor gives $100,000 to a university and specifies that it is to be used to give annual scholarships for the next 15 years. If the university can earn 4.3% interest, how much can they give in scholarships each year? So this is going to be a withdrawal because we already have the $100,000, and then it's the idea that we're taking money out of that account to pay these scholarships. So we have this will be a payout annuity. And this will be A equals 100,000. And N is equal to 1 since we're withdrawing once per year. T equals 15 since we're doing this for 15 years. And R is a 0.043. And we want to find what the withdrawal amount is because that'll determine the scholarships. So 100,000 equals D times, and then we're going to have 1 minus, and then in parentheses 1 plus 0.043 over 1 to the negative 1 times 15 all over 0.043 divided by 1. All right, so 100,000 equals D times a value coming from our calculator. So let's go ahead and plug in. See, we'll have division, 1 minus 1 plus 0.043 to the negative 15 all over 0.043. So we're getting a 10.8887. All we want to do is take 100,000 divided by that last answer. So we're getting a value of D of 9,183.80. So just copy that down. So D equals 9,183.80. So that could be the scholarship amount that we give each year for 15 years with this amount that a donor gave of $100,000 and having this interest of 4.3% each year. So for these scenarios where we're solving for D, you'll just need to kind of separate up the steps, but we can do it with these values and using our calculator to help out.